Hello, and welcome to the latest webinar on Fibre Channel, sponsored by the Fibre Channel Industry Association. In this presentation, we're going to be demystifying the Fibre Channel Speedmap, which may be unusual to people coming in to Fibre Channel from an Ethernet networking world. Well, today's presenters are two gentlemen who are very well known in the Fibre Channel logging sphere, and we're very excited to have these two rock stars in the house. We've got Tony Bourke, an instructor and consultant who teaches and implements technologies like data center networking and Fibre Channel. And we also have Dave Alexander, who has spent over 20 years in support, administrative, management, and instructor roles. And there are also rumors, though unconfirmed, that Dave may have been the fifth Beatle. But both Tony and Dave design next-generation data centers, helping customers make sense of the rapidly changing storage landscape. Both Tony and Dave have written extensively on Fibre Channel, as well as Fibre Channel over Ethernet, and both have several years of experience architecting, implementing, and deploying Fibre Channel SANs for many data centers. We're thrilled to be able to have their expertise to draw from. Of course, my name is Jay Metz, and I'm going to be your MC for today's meeting, and I will be the question wrangler a little bit later on. Now that the introductions are out of the way, allow me to give you a couple of insights into the platform that you're using. If you've never used the BrightTalk system before, you'll notice that there are a few buttons next to the presentation window. The first button to notice is the question button. At any time during the presentation, you can ask us a question, and I will do my best to make sure that it gets asked. If we run out of time, or if we have to defer the question until later, we will be collating all of them for a Q&A blog that we will be posting at fibrechannel.org. The other button I'd like to draw your attention to is the ratings button. We take your feedback very seriously and encourage you to leave comments and rate the presentation at the conclusion. If there are any subjects you'd like us to cover in the future, you can feel free to make those suggestions in either the question area or in the comment at the end. Finally, and I'll get this out of the way now, these slides will be available for you after the conclusion of the presentation. The link for where to find them will be shown at the end of the presentation. Yes, we're tricky that way. So now, finally, I'm going to pass this over to our speakers. And I believe, Tony, you are the current victim, correct?
That's correct.
All right, you're on.
Okay, hello, everyone. My name is Tony Bourke. And first off, let's discuss the agenda for today's topic. We've already done introductions. We're going to talk about the differences in systems and networking. We'll talk about the product and interface naming. Talk about encoding and overhead, and discuss how to compare Fibre Channel and Ethernet speeds, as well as a Q&A at the end. So, to start it off, let's talk about what we care about as system administrators versus what we care about as network administrators. I've been a system administrator as well as a network administrator before, and typically in the system and storage world, we care about bytes per second or megabytes per second. In the network world, we care primarily about bits per second. So that's some of the historical background behind some of the differences we're going to see coming up in Fibre Channel and Ethernet and how we measure speeds. Another thing is system and storage administrators, we tend to see speed as payload throughput or for example, SCSI throughput. Whereas network administrators, we see speed as raw throughput, and we'll talk about the differences between those two as well. So one thing, this is something I got from Dave Alexander, and that really kind of clinched it to me in terms of the differences in how Fibre Channel and Ethernet talk about speed. In Fibre Channel, the goal is for every gigabit of the product name, so 1 gigabit, 2 gigabit, 8 gigabit, the goal is to provide 100 megabytes per second of payload throughput. So 1 gig equals 100 megabytes. So think about that as we talk about the speeds and feeds today in Fibre Channel.
Yeah, that's a great point. That's a great point, Tony. So this is the first time speaking. This is Dave Alexander. I think it's important to call that out in terms of the terminology, and that's the purpose of this presentation. But I think that it's important to note that the reason that this has become a topic, and the reason that we're having this conversation, is that because typically storage administrators, systems administrators, were talking amongst themselves on these topics. the understanding of megabytes versus megabits per second was implicit, right? It was because everyone was speaking the same language. And now that we're seeing a convergence of technologies and more ways of accessing storage, we now have more people joining those conversations. So the idea that everyone is speaking the same language becomes very, very important.
Exactly. And since we see more convergence for technologies like Fibre Channel over Ethernet, Fibre Channel, we're now Fibre Channel is being used for NVMe. So Fibre Channel and Ethernet are being brought up in situations that maybe they hadn't before, and they do talk about speeds, and they talk about them slightly differently. So this is one of the goals of this particular webinar, is to explain the differences in how Fibre Channel and Ethernet talk about speeds. Now, first off, let's talk about speed name misnomers. Both Gigabit Ethernet, or both Ethernet and Fibre Channel, have what you might call product names for the speeds, like 1 gigabit Ethernet or 1 gigabit Fibre Channel. But neither of them are terribly accurate when it comes to the actual link speed. So if you take a look at the column, or take a look at the table on the bottom here, we have 1 gigabit Fibre Channel, and we have 1 gigabit Ethernet. Those are technologies that have been around for a long, long time. If you take a look, they both use something called 810 encoding, and we'll talk about that in a second. The throughput for them is very different. And also the baud rate, the rate of which the ones and zeros are going through the interface are different as well. You'll notice that 1 gigabit Ethernet is not actually 1 gigabit Ethernet. It's 1.25, and we'll talk about that as well. So the names, so it's just something to keep in mind when we talk about gigabit Ethernet or 10 gig Ethernet, and we talk about something like 16 gig Fibre Channel or 32 gig Fibre Channel, those are names. Those are, we essentially call them product names. They're not actually the speeds that are running on the links. And what they mean is slightly different in Ethernet and Fibre Channel. The two things that we will talk about are the baud rate, which doesn't account for encoding, doesn't account for headers or payload, and then throughput, which is either raw throughput, which is payloads plus headers, or payload throughput, which is just the throughput you get for the payload. So it doesn't account for or it doesn't take into factor the headers. So real quick, 810 encoding, if you're probably familiar with this in the Ethernet world and the Fibre Channel world. In order to send bits over a wire or over a fiber optic link, we need to add a couple of extra bits. They balance out the ones and zeros. The electronics like to have the ones and zeros kind of balance out for DC balance, aids with clock recovery. And of course, it's inefficient. We lose about 20% to overhead. So for every 8 bits that we want to send, we have to send an additional 2 bits with the 810 encoding. And that's something that both gigabit Fibre Channel and 1 gigabit Fibre Channel and 1 gigabit Ethernet both use. Fibre Channel runs at 1 gigabit, and the actual baud rate is 1.0625. So if you do the math, if you divide 1,000 megabytes per second divided by 8, you get 125 megabytes per second. So 1 gigabit should provide 125 megabytes, but it doesn't because we have that overhead. So we only get about 100 megabytes of payload throughput. So there's no increase in speed to make up for the overhead of the 810 encoding. However, there is a slight increase of speed, 6.25%, to make up for the headers, so that we can say that we can send 100 megabytes of payload through Fibre Channel for every gigabit, or for every name, for a product name called gigabit. On the Ethernet side, we do it a little bit differently. 1 gigabit Ethernet, the actual speed is 1.25 gigabaud. So the ones and zeros are running at 1.25 billion times per second, or trillions, I forget giga what that translates to. So they increase the speed about 20% to make up for the overhead of the 810 encoding. However, there's no increase in speed to make up for the headers. Now, historically, Fibre Channel payloads have been primarily SCSI. So if you take a look at the Fibre Channel frame here, we've got 4 bytes for the startup frame. We've got 24 bytes for the Fibre Channel header. Then we have the data field, which has 64 bytes for some optional headers. But basically, it's 2,048 bytes of payload, and that fits very nicely with a SCSI message. So primarily the primary payload of Fibre Channel has been SCSI. There have been times when we could run IP over Fibre Channel. I don't think those drivers are updated anymore, and no one really does that. But primarily it's SCSI, and now of course we're talking about things like NVMe. On the Ethernet side, of course, it's kind of the jack of all trades. So historically, Ethernet payloads have been everything from IPv4, IPv6, encapsulated there. We've got ICMP, we've got Fibre Channel over Ethernet without any IP, we've got HTTP, FTP, SNMP, we've got fixed width headers, or fixed length headers and fixed position headers like we have with IP and Ethernet. So those are header sizes that are fixed, a known quantity. We have header sizes that are quite variable, such as HTTP and the other layer 7 protocols, which tend to have variable size headers. So we don't really know how big the payload's going to be because we don't really know what the encapsulation is going to be. So we can't really take into account the headers and discount them and increase the speed a little bit to overcome them like we can in Fibre Channel. So in Ethernet, we're talking pretty much about raw speed, just how fast can we get an Ethernet frame through the system, and that includes the headers. So payload throughput versus raw throughput. On Fibre Channel, we typically talk about payload throughput, so we're talking about the payload, the SCSI messages. The speed has been bumped up a little bit to accommodate the headers so that we get true payload throughput. Sometimes on the Ethernet side, we do see this on the back end of Ethernet switches. So, for example, Broadcom makes an Ethernet chip like the Tomahawk or the Trident. These are popular chips used by many vendors. The speed at which the links talk to, if you have two Broadcom chips talking to each other, they will often use an encapsulation called high gig 2 that adds an additional header onto the packets going back and forth. The speed between the chips is increased slightly to overcome to overcome the headers there, so we get the packets get their full throughput. On the networking side, we do payload plus headers because we don't know what percentage of the packet is going to be headers because we have different encapsulations, different headers, etc. So we don't really talk about that in the Ethernet world. So of course, it's a reasonable choice when multiple types of traffic with different header lengths and variable header lengths and so forth are talked about. So in the Fibre Channel world, it's a little bit simpler. At least historically, it has been simpler because we've had that one primary payload. Where on the networking side, we've got a variety of payloads.
Yeah, the only thing I would also add to that is you also have to consider the fact that as a dedicated, a dedicated storage network, Fibre Channel was designed at a point where traditional networking was already very much going down a particular path in terms of encapsulations, in terms of technologies, and there was already a very established method for describing speeds, the megabit eras, and so on. So with Fibre Channel, the intent was very much to simplify that conversation, and again to the point that you made earlier, that the predominant protocol running across that was SCSI. So the people having those conversations were storage and server administrators who do think in terms of megabytes as opposed to megabits.
Yeah, absolutely. And from a historical perspective, Fibre Channel has been a purpose-built network, and the purpose, of course, is to move SCSI packets. It's where we have things like buffer-to-buffer credits. SCSI does not tolerate loss very well, so that's why we have the lossless fabric. Whereas Ethernet networks run all sorts of historically have run all sorts of traffic. So. One of the things that has caused confusion in the past couple of years is in the Fibre Channel and Ethernet world, at least when comparing the two, has been the move to 6466 encoding. So with 60 gigabit Fibre Channel, the encoding moved to 6466. That's true for 10 gigabit Ethernet and beyond as well. So for every 64 bits, 66 bits are sent across the wire. So we only lose about 3% overhead instead of 20%, which is much more efficient. But the goal of providing 100 megabytes per second of payload throughput per gigabit, and I put that in quotation marks because that's a product name, doesn't actually represent the speed of the link either in Ethernet or Fibre Channel. It never changed in Fibre Channel. So the goal is still to provide 100 megabytes per second for every gigabit of the name. So 16 gigabit Fibre Channel runs at, gives you 1600 megabytes per second, or 1.6 gigabytes per second of payload throughput. But it only runs at 14 gigabaud, 14.025. So when you think about it, if you compare Ethernet and Fibre Channel, 16 gig Fibre Channel, you might think of it as, if you want to compare it to Ethernet speeds, you might consider it 14 gig Fibre Channel, but there's a couple of differences which we'll talk about. So again, the purpose of the goal of Fibre Channel is to provide payload throughput, and in Fibre Channel we tend to double. And so we've got 1 gigabit Fibre Channel is the name, 1 GFC, 100 megabytes of throughput, 4 gigabit Fibre Channel, 400 megabytes of throughput, 32 GFC, 3200 megabytes of throughput, so on and so forth.
Yeah, the important thing to note there is that, as the last slide and this slide both show, it's about providing predictability. The thing about the storage world in particular is we're always very concerned about storage performance, but also in our designs when we're taking into account fan-in, fan-out ratios, those types of things, which may not be typical in, say, an Ethernet design. Having this predictability in terms of if I'm going to migrate an architecture from, say, 8 GFC to 16 GFC, even though those two products used different encoding mechanisms, I can still rely on the fact that that performance is going to be predictable, and the point that you made that it's double what the previous generation was, even if the underlying encoding changes. The same can be said in the Ethernet world, where there needs to be something predictable. We just handle it in two different ways and two different terminologies, really because of the historical, as you pointed out, the historical purpose-built nature of Fibre Channel.
Right. Yeah, predictability. And we want, and of course, in Fibre Channel, because it's a server, it's a storage, it's a server technology, we tend to think about it in megabytes per second or gigabytes per second. So that's really what we're looking at. The 1 GFC, colloquially we call it 1 gigabit Fibre Channel. The official name is 1 GFC. That's a product name, but what we're really looking for is the payload throughput. So when we're comparing Fibre Channel and Ethernet, what we wanted to look at is the throughput, the transfer speed. So we look at that here. I've got a list here of common Ethernet and Fibre Channel speeds and feeds here. Actually, yeah, this one right here. So we compare throughput to, if we want to compare speed between Ethernet and Fibre Channel, don't look at the baud rate, don't look at the name, the product name like 10 gigabit Ethernet or 8 gigabit Fibre Channel or 8 GFC. Look at the throughput. So we have here the third column here. That'll really tell you the right comparison between those technologies. So if you're looking at both technologies and want to get a good idea how to compare them, take a look at the throughput. There's one difference here to keep in mind is we have to remember that in Fibre Channel we're talking about payload throughput, and in Ethernet we're talking about raw throughput. So raw throughput is payload and headers, and in Fibre Channel we're talking about throughput in terms of just the payload. So the headers have already been accounted for in terms of increasing the speed a little bit.
So Tony, why would we be doing this comparison? In what circumstances are we going to be looking at comparing an Ethernet throughput to a Fibre Channel throughput?
If you're evaluating whether or not to go with an Ethernet storage platform, such as iSCSI or Fibre Channel over Ethernet, or if you're, versus a Fibre Channel storage platform, if you're looking at an NVMe, which is a new way to handle high-speed flash, low-latency flash storage. If you're looking at those solutions, there are fabrics that are based on Ethernet or fabrics based on Fibre Channel and fabrics based on InfiniBand for that particular technology. So if you want to take a look at those technologies, you want to get a good look at the differences between them. The fair comparison, or the best comparison, the most apples to apples, it's not quite apples to apples, but the best comparison is looking at the throughput and not the link speed.
Fair point.
So I think that about covers it. So conclusion here, historically, Fibre Channel and Ethernet discuss speeds differently, and there are historical reasons behind it. It's not trying to pull the wool over anyone's eyes, or it's not trying to be deceptive. It's just the way that, it's just the historical perspectives. Fibre Channel came from a server world. Networking came from, of course, the networking world, the interconnecting devices network, that world. So they think about different things. So to compare speeds of Ethernet and Fibre Channel, look at the throughput rates. So take a look at the speed map. The Fibre Channel Association has a nice speed map. And you can compare that with Ethernet throughput rates and look at it, and not so much the link speed, because both in Ethernet and Fibre Channel, the link speed is actually not, is a misnomer, because again, if I'll go back to this slide here, take a look at 10 gigabit on the second row, take a look at 10 gigabit Ethernet. It runs at 10.3125 gigabaud, so it's not really 10 gig, it's 10.3 gig, or 25 gig is 25.78125. That's to overcome the slight 3% loss you get with the 6466 encoding and so forth. So both of them, both Fibre Channel and Ethernet, their speeds are misnomers because they don't really tell you exactly what the speed is on the link. So take a look at the throughput.
Yeah, and I think I would expand on that just a little bit in terms of comparing the two. The problem with comparing these two technologies is that we are moving into a world where we have fewer and fewer dedicated protocol-specific networks. And so, to the point made earlier about historically SCSI being the protocol carried across Fibre Channel, to talk about payload throughput makes a lot of sense. If we try to compare that directly to Ethernet, that really only works if we are talking about an Ethernet network that is only going to carry one type of traffic. The variability of headers, of payload sizes, et cetera, that you mentioned earlier makes that conversation much more difficult. So I think that's where the speed map comes in really handy, is to be able to get a sense of what the actual performance is going to be across those links.
Right. Yeah. If we're going to compare Fibre Channel to something like iSCSI or NVMe, in iSCSI you've got headers that take up some of that bandwidth. So you have to account for that. So that may reduce your throughput, your payload throughput a little bit. Typically not a whole lot, but those are the kind of the things that you'll want to keep in mind as well. So
we do have a question.
Oh, go ahead.
Yep. I was just going to say we got a question. I actually got a couple of questions to ask. We'll get to this one first. So the question is that wouldn't it be better to compare good put, that is how much you can push through Fibre Channel and SCSI or NVMe, and Ethernet TCP or UDP? Wouldn't be so the actual good put in this particular case is a phrase that I use an awful lot too, which is it's more than just the raw throughput. It's how much work you can actually get done in a period of time. So using that kind of metric, might it be better to compare the good put over the actual throughput?
It certainly would. It's a great question. The challenge, especially when we start talking about putting storage traffic onto Ethernet, the challenge is that again the protocols can differ, but also the amount of workload that you're going to be able to get onto a given link is there's going to be more to it than just the protocol and just the link. You have to take into account TCP processing overhead and so on. Is that being done in traditional host memory and host compute, or is that being offloaded to a NIC? That's very typical. So it becomes a little more difficult than just looking at the link speed. But yeah, it's a great point, and that's where you have to also start mapping what other types of traffic may be sharing those links, and then you would prioritize, or you would model that as far as, okay, I'm going to have X percentage of this type of traffic, which has this type of overhead characteristic, and I'm going to have another percentage of storage traffic that's going to have this type of overhead characteristic, to really arrive at that good put type of a metric. The problem in most cases that I encounter is that for the most part, most systems administrators don't always have a good feel for what that traffic blend is going to be.
And that segues actually into a question that I was going to kind of bring in. So when you two are designing the storage networks, and you're trying to figure out the fan-in and oversubscription ratio, especially with different types of capabilities of the different HBAs and stuff, how do you tend to use the speed map to make those calculations?
That's a good question. It depends on. We look at the speeds and feeds, and I look at the throughput. How much throughput can I get from the storage array, raw throughput? How much can I get from the hosts themselves? And the really simple thing about the speed map, the really simple thing about Fibre Channel is that it doubles the speed, so it makes the fan-in ratios pretty easy to calculate because speed differences are double and so forth. So I kind of almost don't use it because the naming conventions and the throughput rates are so predictable.
Yeah, I would say that the conversation for me often changes depending on who my audience is. If I am working with a traditionally network administrators and architects, the speed map comes in very handy for the exact reason that we're doing this particular webcast. In terms of seeing the relationship between the technologies as they've evolved, the encoding differences, and so on. Because that does differ from the typical way of thinking about it. If I'm working with storage administrators or systems administrators, the thinking is usually already in the megabytes per second type of conversation. So then it's just a very quick, very easy conversation to say, from a payload perspective, if we're talking 16 GFC, it's 1600 megabytes per second. So that's the conversation changes depending on the audience.
Right. And we do have another question that came in, mostly about the naming conventions. And let me see if I can try to synthesize this. It's kind of a long question. But the question is about using the gen terminology for the better choice of the Fibre Channel naming. I'm not really sure where the question is, to be honest. So I'll just read it out loud then. May using the gen terminology be a better choice for Fibre Channel naming? And I noticed the Fibre Channel Industry Association officially adopted Gen 6 terminology, but never blessed Gen 5 or Gen 4. I wonder if this is a proof point that gen terminology is a new recommended approach. Not sure if a similar gen terminology exists for Ethernet. Probably not. This is actually probably for me, considering I'm with the FCIA. The generation technology was adopted for a suite of functionality and capabilities that emerged post 16 gig Fibre Channel. What the Fibre Channel Industry Association wanted to do was kind of encapsulate a shift of a number of different feature sets that were available, not just the physical layer. So the generation technology is the Gen 5 technology, for example, is not an official Fibre Channel Industry Association because that is an independent vendor marketing term. The Gen 6 terminology is specifically for a number of different features. As is pointed out here, there is no similar generation terminology that exists for Ethernet. And I can't speak for the Ethernet group, but I don't believe that is an intention on their part. So hopefully that answers that particular question. Any of you have additional comments you want to make in that regard?
Yeah, I agree with you there. The gen naming, as you said, is more about a group of features than a particular speed and feed, especially as we saw with 32 GFC and 128 GFC, that the gen name does not directly correlate to a throughput. It does not directly correlate to a specific speed, because obviously within that same generation, that same generation bucket, there are multiple throughput options and so on. So I would say that at least for the foreseeable future, given the legacy that exists for Fibre Channel, I think the GFC naming, whether that's 8 GFC, 16 GFC, 32 GFC, I think that naming is probably here to stay for a while.
Yeah, and I think when we go back to look at the different, in fact, I'm going to go ahead and drive this a quick bit to get to that thing I'm looking for. Here we go. When the questions come up as to what these things actually mean, what the 32 GFC, the 128 GFC, and the 16 GFC, all that kind of stuff, what it actually means, even though there are differences in the actual baud rates and everything, you can easily see that, 1 stands to 100 megabit, 2 stands for 200 megabyte. Sorry, I meant megabyte, not megabit. And so the naming convention actually does make sense for the physical speed. The 16 GFC to 1600 megabyte, 32, and so on. And I think that we're probably going to see this continue well into the future, because as long as those numbers go in parallel, it is far easier to remember than the explicit numbers of which kind of baud rates that we're playing with, right? So, I think that one of the things that makes an easy mathematical translation for the naming convention into the actual payload throughput for Fibre Channel. And so, hopefully that can help change some of the, or can address some of the myths that come around. How fast is it? How much throughput is it? This really does wind up being a lot more commonsensical than people try to make it, and hopefully that can become a little bit clearer at this point. I think we're out of questions. Did either of you have any additional comments you wanted to make about the speeds and feeds so far?
Yeah, kind of back to the generation naming. As we mentioned before, Gen 6 Fibre Channel encompasses both 32 GFC and 128 GFC. But I think also just it doesn't seem to be. It hasn't taken. It hasn't taken much effect, or at least not effect. The wrong word. It hasn't reached the pantheon of people don't use that term when discussing Fibre Channel speed. So the colloquial name, which is just a fancy way of saying just what everyone calls it, is we tend to call it GFC. So, see, another question. Don't you find 128 gig misleading? Is it 4 by 3 32 GFC, whereas 64G in the mix? Shouldn't the naming reflect the number of rails or paths that might affect the actual throughput and involve load balancing? That is a fantastic question. So in Generation 6 Fibre Channel, we have two options. We have 32 gig and we have 128 gig, GFC rather. It's very similar to what we have in Ethernet now. In Ethernet, we have 25 gig Ethernet and 100 gig Ethernet. 100 gig Ethernet is 4 25 gigabit lanes, just like 40 gig is traditionally 4 10 gigabit lanes. 128 GFC, or colloquially 128 gigabit Fibre Channel, is 4 32 gig lanes. If you've ever seen the interface for this, it's called a QSFP28 adapter, and the 28 stands for 28 gig. It is not load balanced. Well, it's load balanced, but on a sub-packet level. So it's a true 128 gig interface. It's not a port channel in the Cisco parlance. I forget what Brocade calls when you take multiple individual links and load balance across them. This is a true 128 GFC link, speed link. Just like in 100 gig Ethernet, it's a true 100 gig Ethernet interface, even though it's comprised of 4 25 gig lanes. I don't know where 64G comes into the mix, GFC. Is 64 GFC 2 lanes of 32, or is that a separate standard?
I know that the spec is being worked on, but to be honest, I haven't read it myself. So we're going to have to get that and answer that in the Q&A blog, I'm afraid.
Okay. Yeah, but 120 gig GFC is not misleading because it is a true single interface. It is comprised of 28 gig lanes on the gigabaud level. So 4 32 GFC lanes, but they are not load balanced in like a port channel way. They're load balanced on the sub packet level. Same thing in Ethernet. Like I said, with 100 gig Ethernet or 40 gig Ethernet, both 100 gig and 40 gig are 4 lanes of either 10 gig or 25 gig. So it is a true.
Yeah, by the way, I just got notified that 64 gig is a single lane.
Okay. That's probably going to be the next. I don't think that one's out yet. I don't think there are interfaces you can buy today that have 64 GFC.
No, not yet. No. It's one of those things it's in progress. Now we got to kind of have a back to basics question that I think is actually a really good one to focus on. This person claims that they're new to storage, so I think that we should definitely try to help them along. What is the difference between throughput and the speeds of Ethernet and Fibre Channel? What's the difference between throughput and speed?
I'll take that one. So they're of course related, and it kind of depends on what throughput you're talking about. Are you talking about raw throughput? Are you talking about payload throughput? And the speeds, they're kind of the same thing, but you have to be kind of more specific to get the right answer. But I will say this: Ethernet and Fibre Channel have historically measured them, called them different things. For example, when we talk about throughput in Fibre Channel, we're talking primarily about the payload. So the speeds have been increased a little bit to make up for the headers. So when we talk about Fibre Channel speed and Fibre Channel throughput, we're talking about the payload itself. So 100 megabytes per second or 1600 megabytes per second. That's how fast we can actually get SCSI messages, historically SCSI, but now other as well. How fast we can get through the wire. In Ethernet, we couldn't do that because we don't know what the payload is. Since we don't know what the payload is, we don't know how much of that we have to take into account for the headers, because Ethernet will have a mix of traffic. So in Ethernet, we talk about throughput, we talk about raw throughput. Just how many bytes per second can we throw across a link? That includes headers and it includes payloads. One packet might have an HTTP message inside of it, and another packet might have an SNMP message inside of it. The payload sizes are going to be different. The overhead for the headers are going to be different. So it's kind of harder to talk about payload throughput with Ethernet. So we talk about raw throughput with Ethernet. Again, that's traditionally. If you're going to be comparing Fibre Channel to something like iSCSI or FCOE, both based on Ethernet technologies, then you can get more specific into payload throughput because we're talking about a specific single protocol, a specific single encapsulation or multiple encapsulations, and you can account for the headers that way. So you can do the math and figure out what the actual true throughput is for the payload and Ethernet, but it takes a little bit of work. And you have to know the type of traffic. But in Fibre Channel, we primarily know the type of traffic. I hope that wasn't too long-winded of an answer for your question.
Hey, by my standards, it was remarkably brief. Okay. Well, we've managed to go through all the questions that have been asked. We will, of course, post a Q&A blog at fibrechannel.org to go into a little bit further depth on those questions that we've already talked about, so that you don't have to memorize them just from the webinar. We do hope that you will rate the webcast, and we value your feedback tremendously. If you've got any additional suggestions of what you'd like to learn about Fibre Channel, we'd be more than happy to take those suggestions and hopefully turn them into a real webinar. We do announce our presentations and our events on the SCIA News Twitter handle. And so our next webcast is going to be on June 15th. For those of you who are new to Fibre Channel, we're going to be doing a fundamentals class, so to speak, where we're going to be talking about the basics of how Fibre Channel actually works. And it's something that a lot of people might find particularly useful, especially if you're coming into this technology from an Ethernet perspective. There's a couple of things that are very similar and a couple of things that are somewhat different, so knowing the differences between the two can be pretty handy. I'll go ahead and leave this up here for the time being, but I want to thank everybody who took the time out of the day to come and visit. Please do not forget to rate. And I want to thank Tony and Dave for their time today, and I really appreciate the work that they put into explaining all of the numbers to everybody. Thank you so much, guys.
Happy to do it. Thank you.
My pleasure. Thank you.